And we're back. It's time to sort it out with Mr. Swartout. Here we have work done by a tension force. However, that is applied at an angle, so that introduces some complications that we need to deal with. So we want the force normal, we want the work done by tension, and we want the final velocity. You can start by breaking down that tension force into components, F sub Ty, F sub Tx, and we can do a little trigonometry here and come up with an expression for F sub Ty. It would be the force tension times the sine of the angle. Opposite over hypotenuse. Do a similar thing for the x component, Ft cosine theta. So then let's think in the y direction and made a little diagram here. In the y direction, if we add up the forces on the block, it would be force of gravity down, and then F sub Ty and normal force, the two of those added together, up. So it's balanced forces in the y. That means that we can set the forces in the downward direction equal to the upward. So that's how we get that. So in order to balance the force of gravity, it is the normal force from the table, which is going to be a little less because we're pulling up with the rope. That plus how much of that tension force is in the y direction. So that's our expression for that. Let's rearrange a little bit. We want the normal force, and here the force of gravity would just be the mass times little g. So here's an expression for the normal force. It's sort of that missing piece, the third piece of this free body diagram right here. Okay, then let's find the work done by tension. In this case, only the components of the force that are in the direction of the displacement can do work. So just the x component does work, and then we need to multiply that by the distance. So expand that out a little bit. And here, I wrote this to kind of look like our expression for work, Fd cosine theta. So we need to multiply those three. Then use the work energy theorem, as we have done in a few similar problems. Net work is going to be equal to the change in kinetic energy. So that would be, the net work here is just the component of the tension that's in the x direction. So that's what we have there, times the displacement. Then 1/2 mv squared, do some rearranging, and this formula should get you that final velocity. And that's what you need for this one.